Alright, so previously we have only two constant a and b, so now I'm going to add another component for the graph, so which is going to be a constant c. So c, the position is going to be here, so this is going to be our c. So we're going to graph the function in the form of y equal a sine bx minus c, and also y equal a cos of bx minus c. So it says over here the graph of y equals sine bx minus c and y equal cos bx minus c are obtained by shifting the graph of y equal a sine bx and a cos bx, so respectively, so that the starting point of the circle is shifted from x equals 0 to x equal c over b. So meaning that, so previously what happened is that, for example, if I have a sine graph, so this is how my sine graph looks like. So it starts at 0 until whatever value of the period. But now that if we were to add another component c right here, so what happened is that this c is going to shift our graph left and right. So we have actually seen this before. So if you remember, this is what we have seen in chapter 2, a transformation of graph. So when you have f of x plus k, so when you have plus k, so your graph is going to be shifted left for with k units. And when you have f of x minus k, so the symbol is minus, so your graph is going to be shifted right k units. So I want you to bear in mind plus, so it's going to be to the left, minus it's going to be to the right k units. Okay, so meaning that, so instead of like having a starting point at 0, so now the graph is going to start somewhere else, so whether it's going to be shifted to the left or shifted to the right based on the value of c. Okay, so as we have seen before, so if I have bx minus c, so what happened is that the graph is going to be shifted to the right. Right, because of the minus sign. And when the graph is in the form of bx plus c, so what happened is that the graph is going to be shifted to the right, so depending on this. Right, so this is going to be plus minus to the right, plus going to be to the left. So it should be to the left. And the smaller eraser, and this is going to be to the left. Okay, and how do we know like what unit has to be shifted? So how many units to the right or how many units to the left? So that is going to be a formula that we're going to use for this. So it is going to be, the value is going to be c over b, and this value is actually known as the phase shift. How many units to the right or how many units to the left we are going to shift our graph. Okay, I'm going to start with this example right here. So I have a graph of y equal a half sine of 4t plus pi, and I'm going to determine the amplitude, period, and also the phase shift. So first of all, what we're going to do is we're going to identify the value of a, b, and c. So a is going to be the number that is the most front of the sine or cos, so that is going to be given by a half for this case. B is going to be the value right next to the variable. So whether you're using t or we're using x, so the number that is in front of that variable, so that is going to be your b value. And for this case, our b value is equal to 4. And I would like to remind you, for example, if you have something like this, sine of t multiplied by t plus pi, okay, before you determine the value of a and b, so please expand the bracket first. So the value of b and c. So this is going to be sine of 2t plus 2 pi. Then only you identify that the value of b is going to 2 is, and the value of c is going to equal 2 pi. Alright, so next for our case, going back to our example. So for here, what is going to be my value of c? So the value of c is going to be the value at the back right here, for which this is going to be a value of pi. So c comes after the symbol plus or minus. Okay, now that we have all these values, a, b, and c, so we can start finding the characteristic of our graph. So first of all, so the value of a is going to tell us about the maximum and also the minimum value. So a is equal a half. So from this, we are able to know that the maximum value is going to be a half, and the minimum value is going to be at negative 1 over 2, negative a half. So that is going to be the first characteristic. So the second characteristic that we need is going to be the period value. Okay, so the period value is going to be given by 2 pi over b. So the fact that we already identified that b is going to equal 4, I'm going to have 2 pi over 4. That actually simplifies 2 pi over 2. So meaning that our curve. So one curve is going to be from 0 until pi over 2. So that is where the period stops. Okay, so now that I have the period, so the last component that I need is going to be the phase shift. Okay, phase shift, the formula is going to equal C over B. And for this case, my C value is equal pi and my B value is equal 4. So the phase shift is going to be pi over 4. So is this going to be shifted left or right? And because this is a plus sign right here, so our graph is going to be shifted pi over 4 units to the left because of the negative sign. Left because of negative sign. Okay. All right. So now that we have all this, all this information, so now we can start sketching our graph. Okay, but the most important thing is that I think that you already know how do we put the minimum maximum value. So how do we actually write the value of the period? It's simply going to stop at pi over 2. But what I'm concerned is that is going to be on the phase shift. So whether you know how it's going to be done. So let me show you the graph first. So if the graph is not shifted, your graph is going to look like this. So this is going to be the graph. So this is a sine function. So this is going to be one curve of sine. And because period is equal pi over 2, so this is going to equal pi over 2. And this is going to be 0. And between 0 and pi over 2, so that is going to be 0 plus. If you don't know how to find the middle point, all you have to do is you add them up. So I'm going to have 0 plus pi over 2. So divide by 2, and then you will get the middle point, which for this case, this is going to be pi over 4. So that is how you find the middle points. And of course, and this one as well. So 0 plus pi over 4 divided by 2. In the middle over here, I'm going to get pi over 8. And here, what is going to be the value in the middle? So what you have to do to find the value is that you use your calculator. So just ignore the pi. Simply put 1 plus 4 over 1 over 4 plus 1 over 2 divided by 2. And your calculator is going to give you what is going to be the middle point. And 1 over 4 plus 1 over 2. So divide by 2. So that is going to be 3 over 8. And of course, add up the pi. So this is going to be 3 pi over 8. So that is going to be the middle point. Okay, however, so this is not going to be our graph because our graph is supposed to be shifted to the left. So it's going to move that way. How many units? It's going to be pi over 4 units. So the easiest way to look at this is by having a table. If you couldn't imagine things, simply draw the table. If you could imagine that from the graph itself, so no need to draw the table. So let me put it here y. So this is x is going to shift, and what operation is going to be done? So it's going to be shift to the left. So my x value is going to minus pi over 4 because everything is going to be minus pi over 4 and move to the left. And I have how many important points? As I always mention to you, there are 5 important points that we have to capture on the graph. So there's going to be 1, 2, 3, 4, and 5. And the y value doesn't change. So at 0, it's going to be 0. And here, I'm going to have a value of maximum, which is 1 over 2. Then at this point, it's going to be 0 again. And bottom here is going to be negative 1 over 2, the minimum value. And then it's going to be back to 0. And in terms of the x value, so I have 0, and then I have pi over 8, and then it's going to be pi over 4, 3 pi over 8, and then pi over 2. So now I'm going to have to shift everything to the left. How many units? Negative pi over 4 units. Okay, now all you have to do is, you have to do this operation. So take the value of x and minus that by pi over 4. So therefore, what happened is that here, I'll end up with 0 minus pi over 4. That is going to be negative pi over 4. And for this one, as I mentioned to you just now, you can just ignore pi. So you just take 1 over 8 minus 1 over 4. So let me calculate that as well. So 1 over 8 minus 1 over 4. So the answer is going to give you negative 1 over 8. But add pi to that. So it's going to be negative pi over 8. So that is going to be the value. And then I have pi over 4. Of course, pi over 4 minus pi over 4. So that is going to be a 0. And then I'm going to have 3 over 8 minus 1 over 4. That is going to give us a value of positive pi over 8, and then I have 1 over 2, so divide minus 1 over 4, and that is going to give us a value of pi over 4. Okay, so those are going to be our values. So it's going to start now the period. So instead of like having the function, the graph from 0 until pi over 2, so now our graph is going to be from negative pi over 4 to pi over 4, because now it has shifted to the left. How many units? Pi over 4 units. So now that we have all these components, so I can start sketching the graph. Okay, let me put it towards the middle because we have negative as well. Okay, so now based on the values right here, so I'm going to plot it on the graph. So this is going to be negative pi over 4. Somewhere over here, this is going to be my negative pi over 8. So this is going to be my pi over 8. And this is going to be my pi over 4. Okay, so now I just have to capture the shape. So how does the shape looks like? So it's still going to be the same. And we can use the dot as well. At negative pi over 4, the value is going to be 0. At negative pi over 8, the value is going to equal positive a half. And then it's going to be back to 0, negative a half, and then it's going to be 0. So I just take the value up here and put it on the dot-like coordinates. So let's say this is going to be my 1 over 2, and down here is going to be my negative 1 over 2. All I have to do is connect the dots. So it's going to look roughly like this. Okay, so that is kind of hideous. Okay, so roughly that is how my graph looks like. So if you notice, it still has the same shape as this, so it's just it is now being shifted to the left. Okay, so that is how the graph looks like. So I hope you can try these two examples. So I've prepared you two exercises for you to try over here. So A and B, one for sine and one for cos. And this is how your graph is supposed to look like. So give them a go and try to challenge yourself, so whether or not you understand so what we have discussed in this.